All right, hi guys. There's not a lot of people over here, which is kind of good because I'm really nervous over here. This is my first time presenting at TechEd, and I hope you all forgive me if I make some major blunders. And do remind me to slow down, or if you got any questions, just feel free to speak up. Okay, so today I'm going to talk about the Intelligent System Service. This is a brand new platform that Microsoft has developed to enable developers to get started with Internet of Things applications really quickly. Now, you guys are going to be the first people amongst all the other developers in the world to hear this because this stuff is actually really, really new. And I have special permission to talk about this over here. Before I get started though, I would like to get to know how many people in this room are developers. Developers? Wow. Okay, cool. How many people are solution architects? Oh, we got a few over here. Okay, that's good. And how many people are more marketing and more business side of things? All right, cool, sweet. Then most people would be very happy about this particular talk. Right, so just to give you a bit of introduction about myself, my name is Johnny, and I work at Integer in Seattle, and I have a degree in electrical engineering from the University of Auckland, and my research project has been about smart grid systems, so doing some sort of distributed generation with renewable energy sources. So I come from the embedded world, kind of really low-level stuff. So this thing over here is actually related to that, and I'll just give you a bit of introduction on what exactly is the Internet of Things, because there's a lot of people that's talking about it. Not a lot of people know what they're talking about, right? And then I'm gonna go through the architecture of what exactly is ISS, and then how it brings, so what sort of value does it bring to the table when it comes to Internet of Things solutions. And then I'll go through a bit of developer workflow. So as developers, what do you need to know to get started with this brand spanking new system? And at the end, I'll show you a bit of demo that I've been building for the last 2 weeks. First thing you need to know, Internet of Things is overhyped, right? This is sitting at the top of the peak of inflated expectations according to Gartner for this year. Right, so what this means is that there's a few people that knows what they're talking about, and they have a few success stories around the Internet of Things, but it's more like you hear success stories from the marketing team and you hear horror stories from the developer team, right? The client will come to you with an idea for an Internet of Things application, and they might have different expectation to what you have in mind. And a lot of this confusion comes from the fact that there's a lot of different vocabulary being thrown around when it comes to Internet of Things. People might be talking about machine-to-machine communication. Some people might be talking about home automation. This stuff has been around for a long time, right? And they may not be mature, but they've been around. And then it gets even more interesting when you start considering mobility, mobile phones, and how does wearables come into the Internet of Things. To put it very simply, there's a very simple explanation for this. It is simply connecting embedded devices to the internet, right? Oh, that's kind of duh moment, right? But it actually comes with a few more challenges than what it used to be. It used to be when we have all these machines, people sitting in front of machines, generating data, and then sending that data over to the internet. But now we have machines sitting there, collecting data about the environment using stuff like sensors, temperature, humidity, pressure sensors, that sort of thing, and then start sending those data up into the internet. And that presents a lot of new challenges and new characteristics. And just to expand the scope a little bit, when I talk about Internet of Things, I'm talking about devices that connect to the internet. I'm talking about devices that collect information from the environment. And also I'm talking about devices that can receive commands down. Just think about stuff like smart logs. So if you have a log from QuickSet or something, connect it up to your SmartThings hub, and then you'll be able to open your door once your car drives into the driveway, for example. All right, so let's start with a scenario, just to give you a bit of idea of what I'm talking about. Late last year, a company came to Intergen and they wanted to explore the Internet of Things. They got an idea in mind. This is a rather big company from America, I can't say who, but they are planning on deploying about 2,000 digital signs in retail stores across the country. And so these digital signs are going to be playing campaign videos, advertising video, and these videos may not be the same all the time. They might change them depending on the time of day, depending on how many people are in the store, depending on the season, right? It's a prototype solution that they are thinking about. So we are given quite a bit of budget to play around with existing solutions out there, and also to see if we can build one from scratch. And so we started with the Raspberry Pi because it is kind of the obvious choice when it comes to playing videos. It's got a HDMI adapter. It's really small, it's cheap, it doesn't draw a lot of power. And one of the requirements is to be able to see all the analytics and data that's going up. At the moment, it just plays videos. But this is just version 1. Think about version 2, version 3. They might want to add more stuff like proximity sensors, some sort of Connect integration perhaps. There's some vending machines, Coke vending machines that is able to identify the sort of person you are, like sort of your race, kind of like, are you white, are you black, are you Asian, or whatever. And then being able to choose based on what you choose to buy to see if they can do targeted marketing towards your particular demographic. And so that sort of thing will be very, very useful. This will be crucial in the days to come. And because this will be dashboard that people like marketing managers, that salespeople that will be looking at, we want this dashboard to be as simple as possible. And at the end, of course, you got so many devices, you don't want to walk out there to send updates to individual ones. So you want over-the-air updates. So we identified a few sections of this particular problem that we have to develop or consider if not to develop it in the first version. Obviously, we have the client-side application, the application that plays the videos. And there's also got to be a part that talks to the backend system that gets the new videos down and that gets the new device updates and sort of communicate data back to the server. And there's some problems to this. First of all, the device that we're choosing, the Raspberry Pi, is pretty good for a small run. But when it gets to a lot more devices later on, if they want to add more than just a digital sign to their retail stores, they would need to learn this new device platform. They need to build new communication platforms specific to that particular device. And when it comes to the embedded world, it's not as nice as just in Windows or in iOS or in Android. It's one API. There's heaps of stuff that you have to think about from the networking stack and everything. So, and also we need a message bus to ensure our message get from our digital signs to the server. If the network goes down, we want to make sure that crucial information is cached up in the clients and also on the server side, so that when the network goes back online, all these important commands get sent across the wire. And there's some problems over here. We're using Azure Service Bus to do this approach, and we're using AMQP, Advanced Message Queuing Protocol. And it's a really industry-specific, industry-standard practice to use AMQP when it comes to IoT or M2M solutions. And the problem with the Raspberry Pi is that even though there is a Linux build of AMQP agent, there wasn't one especially made for the Raspberry Pi because it's a variant of Debian There's some slight differences, some libraries that wasn't available. So I had to go into the make file to change things. And, I mean, as a developer who's got quite a bit of time on his hands, I'm all right with that. But if you are given a critical system, you want to really quickly see the capabilities of a platform, you don't have time for that. So you want to have some sort of universal messaging capability. And also alerts and rules that I talked about. Remember, these are not technical people. We can't go into the code to change things. We want to make it nice UI. We want to make it easier for people to change later on. So we need to build that sort of rules engine into our server side as well. And also, there's no point in sending out data up to the cloud without doing some sort of analytics or graphing. So we need to hook into some sort of charting library or even make some sort of integration API so that we can integrate with third-party applications, because we don't want to make a chart tool that is static and rigid, and every time someone asks for a new chart, we have to go in there and modify it. We want that. We want to be able to do maintenance easily and secure over-the-air updates, and think about versions, right? If we have a different version of data model when it comes out, we don't want to break backwards compatibility. And the device onboarding part is the most interesting part of this solution. We were looking around at all these different ways of people doing, sorry, let me start again. All the existing solutions out there, and the way that people do onboarding are not necessarily the best way sometimes. There was a particular platform that was using a single API key for all the devices out there. So if this particular API key is compromised, then, well, they have to change that on the server, and then they have to somehow get this API key down to every single individual device. So we need to have a really good way of doing device onboarding. And what happens if I want to save a bit of money and network traffic and then route all my device data through one particular device? We want to be able to separate the different devices that are on the same network, stuff like that. And also security. Of course, with Internet of Things applications, you have these devices that's sitting out there on the roadside that's probably sending your traffic lights or some sort of humidity sensor that you can, a developer like me might want to take down and start playing around with it and see how it works inside. And of course, you want to have some sort of authorization, security in mind as well when it comes to the stuff that Stephen talked about in his keynote speech, say the internal people. Some people are supposed to see a particular piece of information. And of course, the most important part is also cost. None of the existing platforms out there offer SLA. So that means they could go down at any time, not guaranteed. So we need to think about that. And we can sort of summarize all these problems down into 3 different wants and needs by 3 different parties. Developers want a platform that we can get started with quickly, that we can buy and then get started. And then eventually, if this solution becomes very big, we want to be able to start tinkering around with it. We want to be able to make this flexible. And then device operators like business owners, they want something that is predictable, as in like they don't want to get a new device and then having to have the risk of learning that particular device or learning that particular library. And they want to utilize as much of their existing assets as possible. And lastly, again, there's no point in sending data up to the cloud if you're not doing some sort of analytics on it. And this is where the Azure Intelligent System Service come in. It is built on top of Azure, and it is focusing on 4 different parts. First of all, it is ready-made, it's scalable, it's extensible, and it's cost-effective. When I talk about ready-made, they've already offered you a client library that you can get started and then chuck onto a Raspberry Pi, for example. It's got message queuing, event hubs built in already. It has a portal for you to manage your devices. And lastly, it integrates into corporate security really just out of the box. And it is built on core Azure components from Service Bus, Event Hub. Event Hub is a new service that came out through WPC 2 months ago, and it's built on top of the infrastructure of Service Bus. And it hooks into Active Directory straight away. So if you start with ISS, you can just take the Active Directory that you're given in Azure and then put this in here, or you can, if your corporate account has already got an Active Directory instance, you can put that in. So you get the roles of any administrators, you get device operators, you get maintenance workers, etc. And also it comes with table storage out of the box. It is extensible. All the client libraries that is going to be available are open source. So this is managed code, this is C code, and the OData endpoints on the server side will be able to port to Power BI and Azure ML at a flick of a button. And it's got a whole bunch of REST APIs for you to talk to. The interesting thing about the device portal that they give you out of the box, it's using entirely the APIs from the SDK that you're given. So you can get a portal and just chuck it away and then make a brand new one that's got your company branding. And you can even give this out to your customers. And lastly, it's cost effective. I'm not allowed to talk about the cost, the actual pricing tiers, because this is still in preview. But what I can tell you is that this is a package offering. So instead of paying for these components individually, you get them all in one price. It is more of a software as a service, but kind of like in between that and platform as a service offering. And it is guaranteed to have a competitive pricing model. And again, like Stephen said in the keynote, everything's going to get cheaper and cheaper. It is guaranteed to change. This is how it looks like from a grand scale. This is actually very, very complicated. So let me just break it down into different parts of the system. Right, so on the left side over here, you have the device. This can be any Linux or Windows or embedded chip. And then you take the data and then you chuck it into the messaging endpoint, kind of. And that's where the Azure Service Bus comes in. And then it does all the pops up commands. And then you go into the compute module, which does the rule processing. And then after that, the data goes into storage. And then out on the other side, we have visualization. So that's where the OData endpoints come in. And let's go into this in a bit more detail. So on the device side over here, what we have is a device that has got the agent installed on there, the ISS agent on it. And this device kind of acts as a gateway for any sensors that's connected to it. So these can be separate devices out there. You can connect these, like say the digital sign over here, which has a whole bunch of sensors, and connect that to your, I would say, a gateway device, which will handle the device application, so playing the videos, grabbing the new videos from the service, and also to communicate through a secure channel. And it has two parts, right? So on the top, you have the line of business application, and on the bottom, you have a data provider and the bus agents. Now, the data provider is more of a header file that you define the data that's being sent up to your service, and also defines the sort of actions that you can get back from the service. So say if you want to do an over-the-air update, you press a button on the server side, and then the device over here will get a command and will start doing something. And I'm using the word agent here. It's a really industry-specific term. It's used in M2N a lot. It is simply something that talks over the communication channel, for those of you that didn't get that. Right, so after the data goes from the device, it leaves the device, it goes into a service bus, and it comes into the ingress service. If it's a piece of data, so for example, if a person was to sit in front of the digital sign, then this data goes into the ingress service. And if it was an event or an alarm, for example, if the device senses that the battery is low or if the temperature is too high around it, it will go into the events or alarms, which goes into the front door service on the Azure. And this is the two APIs that you use when it comes to the REST endpoint. Moving on. Once the data gets past that stage, it goes into the compute engine. It goes through the data processing pipeline. And this big box over here with the dashed lines is the rule sets. This is supposed to come in today's update to Azure Service, to ISS, which is apparently happening as I speak right now. So let's hope the demo is going smoothly. After that, it goes through the data integration services. This makes it easier for you to choose the type of storage that you want your data to go into. Like I said before, Azure Table Storage is the default one that you use, but you don't have to use that. You can use stuff like SQL Azure, and if you got a blob storage account that you want to use instead, go for it. And at the end, the data comes out on the other side through through the egress servers on top. This is the old data endpoint that you can just chuck straight into Azure ML or the Power BI suite of tools. And Azure HD Insight is available too if you want. So this is kind of like how the system fits together. And I mean, if we look at this, the messaging part of things is more or less of an API. The storage part, it's kind of boring. The OData endpoint is really, really simple. It's just an endpoint, right? The device agent is what's interesting over here. So let's take a closer look at that. We get quite a few client-side agents available out of the box. We get a managed.NET library that you can use in your WPF applications. We get a C library that you can use on Linux and Windows. The Windows C and Linux C is actually using the exact same code, but they just compile specifically for that platform. And of course, you can not use the agent at all and just use the API. And the agent is just to make it easier for you to communicate to the service. Right. These older agents that's going to be available is going to be open source under the Apache 2.0 license. And on the right over there, your right over there is all the platforms that's going to be supported off the box. Of course, we have the Windows devices and the Windows embedded devices. And then going down, you have Linux and also Windows on Galileo, which my friend Mo here has did a session on a few days ago. It's basically a little headless Windows running on microprocessors. It's really cool. Oh, and what's not mentioned there is Android and iOS is going to be supported as well. And so this opens up quite a few possibilities when it comes to connecting your device. You might connect it without the agent with the REST endpoint. That's all right. If your microcontroller is not supported in public preview, or if you are not too sure about using the agents, then this is what you use. You can connect it up to the agent in a one-to-one fashion. That's all fine and good. But what's interesting is on the right over here, we might have multiple devices on the same network. We might have a gateway device that sends up data from all these individual devices. And this is where things get interesting. When it comes to buying the ISS service, you're charged per device, right? Per X amount of data per device per month. And when you have this in a gateway fashion, what you can do is you can batch up all these individual devices out there. And the service already figures out that you are one device, you are actually sending on behalf of different devices. And it remembers that. And so it doesn't charge you extra for all these different devices that's dangling off your gateway. And so this gateway doesn't have to be talking through TCP/IP as well. You can have stuff like Zigbee or Z-Wave, these mesh networks that's really popular with home automation. Or even have Bluetooth LE and RF. So like I said before, Android and iOS is going to be supported. Just imagine all the Bluetooth devices that you got on your body, fitness trackers, all those sort of things become a device in this particular service. And I just can't wait to see what people do with that sort of configuration. And it is time for the demo. All right, fingers crossed they're not doing the update right now as we speak. Switch it over. This is the code that I got over here that's running on the Raspberry Pi. And just to show you what the Raspberry Pi is doing, Right, so over here, what it has is a ultrasonic range sensor on the right. On my right, your left. And as you can see, if I move my hand in front of it, it's gonna just kind of say how far away my hand is, right? And that's about it, really. This is a very simple demo that I want to show. And so what I'm going to do is I'm going to turn this range sensor device into an ISS connected Internet of Things thing. Oh yeah, I should do that. That'll be fun. Where's Jamie? All right, so this is the data model that I have running in the Pi. And on top of here, I'm including a whole lot of header files that comes with the agent library. And I'm defining this thing as the integer range sensor. And it's kind of like, you see how it's got V1 at the bottom? This is compulsory. So if I was to go from V1 to V2, I'll just put a V2 down there. So this kind of supports the multi-versioning and multi-data model. Right, so we have my account name, the name of the device, and also, okay, that's the name of the device. And this one is the namespace. And going down, I'm defining the type of data that I can send up. I can have a class that has got a string, double, and a date time value. Now this is really C code, so if you guys are used to manage code, you're gonna have to bear with me here. And then we have a class that can contain another class. So when I send stuff up to ISS, I can define a whole bunch of little data points down here, data packet. And again, I'm just defining this as a property that I'm sending up. And then I'm defining the type of alarm I can send up. A alarm is a special type of event, right? I think it receives a higher priority when it goes up to ISS, and so it gets processed a bit quickly. And it has a special property called severity, which I'll talk about in a minute. And this is just saying, oh, I'm sending up an integer called sensor type, and I'm sending up a double code value. And I'm saying this is the name of this property is min distance. And then these are the actions I can define on the device. So this is a method over here that's going to get called whenever I call this action on the server side. Right? So I'm predefining the parameters that's coming in, and I'm also doing something with that particular parameter. And in this case, I'm turning on the alarm when it is sent a new value. All right. Every single data provider over here has to do this data provider initialize event. And it is saying, okay, what do you want to do now? The service is started. For my case, I'm just wrapping my entire line of business application in here, which is just to read the data coming back from my distance sensor. And as you can see, I can't get any lower level than this. I'm turning on the pen, and then I'm waiting for the time to come back, for the time for the pulse to get sent out, and then get detected back here, and then it kind of sends a high when it comes back. And then so it's kind of like how Sonar works in a nutshell. And then I'm just saying, okay, I've done my initialize my data provider, and now of course you have so what happens when your application leaves. Right, so over here, what I'm saying is I'm checking to see if the distance coming back is less than 10 centimeters. And if this distance is less than 10 centimeters, I'm creating this alarm called min distance, and I'm giving a severity of 1, setting an alert back up. And then every single time a new piece of data come in, I just go, I'm creating a new piece of data with the date time field. Pretty similar stuff, right? So let's see this in action. I have this, so I'm running this code over here to show the distance. This is my sort of working directory. And so I'm going to register the data model that we see over here. And what it's doing is it's already being made. I don't want to show you the make process. It's really trivial. And so it is uploading the model schema up to ISS service. So whenever you have a new device coming in and you want to register a new set of data model, you have to do this once. And you can do it through on the device itself. You can do it through the REST API, or you can do it through the management endpoint. It doesn't really matter, as long as you tell ISS what sort of data you're sending up. And I'm gonna start the application for you, and let's see what's going on here. It's contacting the front door service, and then it's getting the value. So I have it printing out over here. So every 3 seconds, it sends up a piece of data up to ISS. And that's kind of how it makes sure that you are not spamming the system. If you do it too often, they allow you to really quickly send up a whole batch of data, but after 5 minutes or something, if you reach a 5-minute threshold, it's gonna start throttling your device. So as long as you make sure that the data you send up within a 5-minute window goes is not too much, then you can send out as much data as possible within as short amount of time as possible. So you just want to conserve that, right? All right, so I haven't got the alarm turned on just yet. You see how I can put my hand all the way over here, and it's still doing exactly what it was doing before. So I'm gonna send a request to a REST request to the service. Over here, I have my endpoint. I'm saying, look for a device, Raspberry Pi, and then I'm invoking an action with the API version specified. You have to specify the API version because this is still in preview. And then what I'm saying is I give it the data API key over here, and I'm saying this is the account that I'm sending it on behalf of. And then over here, I'm just saying, okay, I'm calling this particular method with this value, and then send. Okay, 200, awesome, everything's going well. So if I scroll up a little bit, you see that, oh, I can't really stop it, but you see that there was a post, it's gone now. But there was a bit of code that says post, so it has received the command and it has now turned on the alarm. So if I was to move my hand over here a little bit closer, you're gonna see how it's started sending up heaps of data. That's where the alarms come in. It's saying I'm setting up an alarm with a severity of 1. All right, so let's go into the dashboard and see what's going on here. So this is just the normal Azure management portal, and I have my 2 different accounts over here. Here's where you see all your access keys. I don't want to show you guys that. Going here, I have the different endpoints that's available, and then I'll just start managing the portal. Now this is all in preview, so what you're seeing, all the UI over here is going to change. But this is basically all the devices that I got in my system. I go in there, and then you see what it is. It's called RPI, really simple stuff. I go into the alarms, and I see that I have 12 alarms that has been sent up just now. All right, you go in there. This has been sent at 5:06 p.m., which is just now, and with the actual distance that was sent up. That's cool. And so over here, what you have is the concept of having device groups. And basically, these device groups are kind of like filters. So if I go into all devices, over here on the left, you can say, okay, I only want the active devices that's in my system. I only want the registered devices in my system, et cetera, et cetera. And so if I go into here, and then let's see the data that came in just now. This is actually still coming in. Right, so this is the, where's the distance? Oh yeah, so this is the distance that's sending up right now, because I'm actually apparently 40 centimeters away from the device. So let's open this up in Excel and see the data coming in. I get a OData endpoint, which I would just put into Excel. Sorry. Create a new data. Data feed. And then over here, I'm just typing in the name of my account and then my access key. It's okay, it goes off the page, so you can't really screw up my demo. Yes. All right, and now we have the data coming into Excel. I think it's downloading heaps of data because I've been sending up a lot of them. All right, so I see my device over here. I go in there and I can describe this table if I wanted to, but I don't want to do that. I'm gonna just put it into a simple table format. There is a lot of charting tools that you can use with Power BI. Unfortunately, I know none of them. So a table will be good. So yeah, so now what you have is a device that you got in your field that's sending up data all the time. And then on the other end, you have Excel, which is the tool that all salespeople and marketing people kind of expertise at. And I can't really deal with it. So let's, yeah, so that's the demo over here. And let's switch it back to my presentation. Okay, everything's working. And so that's kind of a very brief overview of what you have to do to get a device sending up data. But before that, you have to do quite a few things. First of all, you create the account in Azure. You go into the SDK and then start defining the data model. I think this part is the most difficult part in any solution, really. Like once you nail down the sort of data you want to send up, and the sort of device properties that you got, the kind of alarms and events and actions you want to take down from the device. Like once you got that sorted, you're pretty much sorted. That's repetition, but I don't care. And then at the end, you just plug in the endpoint and key values to your device. And then after that, you can actually do everything in a portal or through the REST API. So again, you're not forced to use what's being given to you. You're open to do whatever you want with the API. Right, some case studies. Now, these two companies are what Microsoft has been sort of advertising with their intelligent system service efforts. And if you were to go into the links that I'm gonna post in my resources later on, There'll be a lot of references to this. And just to give you a bit of overview on what they do, ThyssenKrupp is a elevator manufacturer in America. They're a huge company. Actually, they came out of Germany. I apologize. And they are actually in charge of doing the new elevator that's in operation at the World Trade Center 1, the new World Trade Center, which is kind of cool. And so they wanted a way to monitor all the elevators that they've sent out to companies and to buildings all over the world. And they want to do some sort of predictive analytics on it. So they can actually predict if an elevator was to fail within the next few weeks and then start sending out a service person just in time to replace it or maintain it. And that's using the power of Azure machine learning service, which you can have a look later on. It's in public preview right now. And on the right over there, we have Talent Technologies. They are the company that owns all the equipment that London Underground uses. So all the tubes in London, all the equipment that you see belong to them. So they want to check the environmental values in a particular tube or in a chain or in escalators. For example, actually escalators is a really cool thing. Did you know that if a few escalators go down in, say, Waterloo Station, for example, the people that's being back-checked by not being able to move up the stairs fast enough, they're going to, it will eventually ripple out and then shut down the entire underground in London. That's kind of scary, right? So they want to make sure that this sort of thing doesn't happen. They have these sensors in the escalators that measure how much vibration it's getting, and apparently that's how they wear down the escalators. And then when it gets, the vibration gets to a certain level, then the elevator will shut down because of safety reasons, right? So they want to prevent that from happening at all. They used to have these two server boxes, literally PC boxes, they sit in a particular room that's got a webcam pointed at it. That's their secure surveillance kind of system. Yes, it's a surveillance system consists of a webcam. So someone was once walked into the room and then they realized that the webcam has been off for a long time, right? They don't want that sort of thing. They want to move to the cloud. They want to move all the data into somewhere where it's really safe, right? So this is why they chose ISS. They want to make sure that the whole thing is moving smoothly. So instead of talking about London and America, let's talk about New Zealand. New Zealand is actually a great opportunity for us to start doing IoT applications because think about it, we have a beautiful country. We are sparsely populated. We have a bunch of people that is really passionate about the environment, except for the acts and conservative people. But still, everyone else is really, really concerned with the environment, right? So we should do stuff like checking forest health, checking how our native forests are doing, checking pests, making sure our native species are not endangered. Water quality, livestock is a big one, right? Just think about all these sensors being spread out through all these regions and just collecting data for us to improve our way of life. And that's sort of the sort of thing that I really want to see from you guys, right? Go out to your customers and start doing these things to make our world better. And that's it. Thank you very much. These are some resources. Now I got a slide up here, so if you got any questions, feel free to ask. Sorry, what time is it right now? I hope I'm not going for. Right now it's in limited private preview. Therefore, it is not available, and I don't think that information is available yet. It is going to be available before Christmas, so you'll be able to see. Yeah, it's coming. It's coming. Next. Sorry?
Have you got any strategies for hacking data? Because if you're submitting data as text, right, you think of it like, whereas some of these
Right. So that really depends on the type, the tier that you go for, the different pricing structure. And again, that stuff is not public yet. Everything's still in planning. But I think temporarily, if you got an application that wants to send out a whole lot of data, you can batch them up. Like as in, like you can really frequently send up data in a short period of time. As long as your overall quota is not exceeded, then you're good. Like that might be in a day or in a few days. I don't know. Thank you. Anyone else?
So you talk about each device. So like, what is the, how, if you're looking at the device, what type of I/O would you be looking for in order to interface
Right. So right now it's sending up JSON data. You was right. Like everything is all JSON communicating between the client and the service bus because, well, it's just using the service bus. Sorry. So what was your question again?
So what other applications can you give, like either that light breathing, like what other sensors are there?
Oh, right. That's anything. Like it's the Raspberry Pi over here is got a bunch of GPIO ports. But if you want to do stuff that's on the Arduino side, there's a whole lot of shields that you can get with the Arduino from Bluetooth, from GPS modules, anything. Like as long as you can get it into a data format that you can start setting up, then you're set to go. And that's the good thing about Internet of Things is abstracting away the device from the actual internet. We are kind of like, we got the device over here that's sending out data on behalf of these sensors. Yeah. Sorry.
Lots of devices out there all capturing data and the data actually posting it together. Can I actually resell that? Or is that something that, like, for example, that sort of data about water quality? There might be council, government, local governments all interested in that sort of data.
Okay.
Is there any point to how that would be as a business to sell that data?
Well, I think you have to talk to whoever owns that data in the first place, right? If you got your own devices out there collecting data, then that data is yours. But if you're collecting devices from sensors that belong to other people, then the data is other people. Like that really depends on who you talk to and how you go about positioning your business. But yeah, of course you can. You can just get one of these devices out there and start collecting data and go to people like Auckland City Council and start saying, hey, I got a whole bunch of data, do you want it? Right. I think that's where the all data endpoint comes in. You can take the data that's coming out of the endpoints and then just get people to pay you for access to a particular endpoint. I hope that sort of answers your question. I'm more of a developer guy. Yeah. Next. Sorry.
How much does it cost the service?
Oh, I could. It's not public yet. It's gonna change. So we can't. It's cheaper than the competition. I actually compared it to one really good competitor, Ethereal's. They offer really great IoT solutions right now, and it's way cheaper than that from what I heard. Yeah.
Can you tell us how the pricing is structured?
I can't. Yep. Anyone else? Yep.
But the source code we were typing, that was the agent for the device, right?
Yeah, so it's open source as long as it's the agent side is entirely open source. So
How extensive of a business rules is required?
sorry?
The business rules side, how open is that? And how extensive is it? How
That is not, they didn't say that that's open source, so I don't imagine it would be. Again, it wasn't implemented in this particular version of the SDK, so I can't give you a lot of information. I'll check tonight. They might have finished rolling it out.
One final question is it possible you can have your own private version of that cloud service instead of having it uploaded somewhere else?
No, you can't.
That will also much giving legal or medical data.
I guess you can use the data integration services that it offers. So if you got your own SQL Azure storage, but I mean, I guess that's still up in the cloud, and your data has to eventually go through the service. The service is a cloud service, so you can't really use that out of the cloud. Sorry. Yeah.
If internet connectivity goes down, is there anything built in that will sort of just build up the data log and sort of post it off at a later date?
Sorry?
If internet connectivity goes down, wherever that device is there anything that will sort of save the data and then upload it at a later point?
Yep. So I tested. I haven't actually tested how big the buffer is, but there is a message queuing mechanism. I suspect it might be using MQP underneath. So the message queues. So Don is got some information on that.
Message queues built into MQP, so that protocol's put on the device. There's nothing inherently in the SDK. There's nothing inherently in the client code, in the agent code, that does queuing there, right?
I think so. I did disconnect it. Oh, right. So from server side, it's definitely queuing, right? I could send a post down, and then my device wasn't even connected. I connected up, and then all of a sudden, the post came down. The client, I did a test, and yeah, I'll find out for you. We can test that right here, actually. Yes.
Are there any restrictions to programmatic access to the data? I'm thinking, data cleanup, consolidation, or even passing it to other services?
So after the data has gone up, you want to make sure that it doesn't stay on the service afterwards. The data integration service over somewhere, it's not here. But on the other side, there was a data integration service. I think there was a API that you can hook into. I'm not too sure about that. I'll have to find that out. But again, there's not a lot of information coming out from what's happening on the server side inside. It's kind of like a black box at the moment. There's going to be more information coming out. Yeah.
You can have no device to the internet. Just mobile internet, or
Right. So right now, by default, the agent uses the network adapter on your device. So the Raspberry Pi has an Ethernet port, and right now it's talking to Wi-Fi through my phone, which is hotspotting through my 3G network. So it is actually going through the mobile network right now in this particular demo. But I think because the client code is open source, if you got 3G sticks on the actual microcontroller itself, or it has some sort of, what's the word? Novel mechanisms to do connectivity, then you can write that part, the communication part yourself, and just do some C coding, and then just wait. Anyone else? Everyone's sitting over here. You all must have got questions.